Today we're going to talk about finding outputs and rate of increase given the graph of a line that models a real-world situation. So what we're going to do is we're going to go through and guide ourselves through this graph and determine what some of it means and talk a little bit about rate of increase or rate of change as related to our x and our y axes. The problem says owners of a recreational area are adding water to a pond. The graph below shows the amount of water in the pond in liters versus the amount of time that the water is added in hours. So we're going to be time versus water. Okay? And so if you look at our graph, each graph has an x and a y axis. And in this case, our x axis is represented as time. And our y-axis is represented by the water in the pond. We can just say water. Okay? And so now we're going to try and figure out how fast, what is the rate of increase as I add water to the pond in time of hours. Okay, so if you look at the graph, it's going to ask us a couple questions down here. And so it says, first, how much water is in the pond at 0 hours? So if we look here, here's 1, 2, 3, 4, all the way to 9, but here's 0 hours. And if we go to where 0 hours happens, it starts with 100 liters of water. So we're going to have the point 0, 100. And all this means is that at 0, there were 100 liters of water in the pond. Okay, so how much water was in the pond at 0 hours? That would be 100. And it's really easy to figure that out because just read the graph. At 0 hours, 100 liters. So now we go and look at the next question. It says, how much water is in the pond at 1 hour? So to figure that out, we go to our x-axis for 1 hour, and we go up the number 1 until we see it intersect with a y value, a y-axis value, and it shows up right here at the point 1, 400. So that means after 1 hour, there were 400 liters of water. And so that's going to be our answer here, 400 liters after 1 hour. Now to find the rate of change, which is going to happen here in a minute, we're going to have to think about what change means. Okay, and so think about that. What does change mean? So the question is, how much does the amount of water increase for each hour that water is added? So every hour we're adding water, and it wants to know how much water is added for every hour. Okay, increase means added. So it's really easy to say, well, after 1 hour there were 400 liters, so the answer must be 400. But that's not true, because we didn't start at 0. We started at 100 liters, and we grew from 100 to 400 over the first hour. And if you look from 100, if you look from 1 to 2 hours, we go from 400 up to 700. Okay, so this is our next hour change. So if you see the pattern, 100, 400, 7, you can see that it is increased by 300 liters. Or we can just do the math. In order to do that, we're going to have to find the increase. So in order to find the increase here, we're going to need to subtract 400 minus 100. And we know that 400 minus 100 gives us 300, and that's our answer. That's going to be our change in liters each hour. So 300 liters each hour. This is what we're going to call rate of change. Rate of change is the way that the y changes over the x, and we'll learn more about that in the next video. In part D says, are the amounts given in part B and C equal? Why or why not? Choose the best answer. So right away we see that 400 is not equal to 300, so we can already say no, but we have to choose why. And the reason why they're not equal is really because 400 isn't equal to 300, but also that it doesn't pass through the point 0, 0. See how it goes through 0, comma 100? That makes them not equal also. So it's no, they're not equal, and also because it doesn't pass through the point 0, comma 0. So for these types of problems, we're just going to interpret the x and y axes and answer the questions as accurately as possible using a little bit of subtraction.